Welcome to eSonMicro-LAB. This is Part 9, C# Methods and Functions. In this tutorial, we will review methods, signature, access modifiers, return type, method name, parameters, method body, and static and instance methods. Please don't forget to subscribe and click on the notifications. Please let me know in the comment section any feedback you may have. Your opinion is very much appreciated. Methods and functions. According to Microsoft documentation, a method is a code block that contains a series of statements. A program causes these statements to be executed by calling the method and specifying any required method arguments. In C#, every executed instruction is performed in the context of a method. Methods are declared in a class, struct, or interface by specifying the access level, such as public or private, optional modifiers, such as abstract or sealed, the return value, the name of the method, and any method parameters. These parts together are the signature of a method. Method's signature. A method or a function is a block of code that performs a certain task. One can say that there are two main reasons to utilize methods or functions. First, methods enables developers to reuse code and reduce development time. Second, maintenance can also be reduced by using methods while preventing code repetition during the development phase. A method signature is composed of access modifiers, return type, method name, parameters, and method body. Here we have a very simple example of a method: public static string, student info, open parentheses, a string first name, a string last name, close parentheses, open braces, a string full name is equal to last name plus first name, return full name, close braces. In this example, public is the access modifier. Static, we will talk about static later in this tutorial. A string is the return type. Student info is the method name. Inside parentheses, a string first name, a string last name are the parameters. A string full name is equal to last name plus first name, and return value within braces are the method body. Now, let's switch to Visual Studios. I have already created a project, so let's take a look at this example. Let's create some variables. A string, first name equal to James, a string last name, Ducey, a string full name, last name, plus comma, space, plus first name, council dot writeline, full name, full name. So what we have here, we have first name James, last name Ducey, and full name will contain last name plus first name. So let's go ahead and run our application. Now, as you can tell, the results are as expected. Full name is Ducey James. Now, let's say that we have few names that we need to add together. So what we could do, the easiest way would be to just copy this, do a paste, and we can go ahead and change all these variables, 1, 1, 1, 1, 1, and 1. And let's change the names, Walter, Sky. Now let's run our application one more time. So here we are. We have full name for Ducey and James and full name for Sky and Walter. Now another way that we can do this is to create a function. For example, public static void print full name. Now here we want to pass two values: a string first name, comma, string last name. Now let's copy all of this and paste it here. Copy first name, copy last name, and paste it here. Now we can come back to our main program dot print full name. So the first thing we have is James. Let's copy this one, comma, and then last name. And similarly for the other one, let's copy all of this, paste it here, and Walter and Sky. Now we can basically delete all of this. So now let's go ahead and run our application again. Now, as you can see, the results are exactly the same. So what have we done? We have created a method that we are passing the names. Instead of typing all these variables so many times, we can just create a method, print full name, and we can pass the information through these variables and then make full name equal to first name plus last name. This would be a much easier way to do it. So if we have 10 names here, instead of creating all these variables for name 1, name 2, name 3, and so on and so forth, we can just create a one method, and then we can call that method and pass the proper names, and it will get printed. Here we have public. This is the access modifier. Static, we'll talk about a static in a few minutes. Void means that it is not returning any value. Print full name is the name of the function or method, and these are the parameters that we are passing to our method. Access modifiers. There are 4 basic types of access modifiers, and they are used to provide a level of security and visibility of class members. Public, accessible for all classes. Private, accessible within the same class. Protected, accessible within the same class or any class that is inherited from that class. Internal, accessible only within its own assembly, but not from another assembly. By default, if a modifier is not listed, all class members are private. Now, time to see some examples. So let's switch to Visual Studios. So in this example, we look into access modifiers, private, public, and protected. So here basically we have a very simple class, student. Here we have 3 variables, a student ID as an integer, 333. We have a string type, student first name, John, and we have another string type, student last name, Master. In our main, we've created an object of the student class, and we are just printing our variables to the console. So let's run our application and see how it works. So as you can see, student ID is 333, student first name John, student last name Master. So what if we change these access modifiers? So let's make the first one private and make the next one protected. And we're going to leave the public as it is. So do we see any changes? Let's run our application again. So everything seems to be the same, no changes whatsoever. So basically, we are calling these variables within the student class, and it really doesn't matter what is the access modifier. This student class can access any of these variables. So it doesn't matter whether it is private, protected, or public. We are able to print these variables without any issues. Now, let's make some changes to our application. First, let's change all these values back to public. Let's create our class program. Now, everything seems to be fine. So now our class is really outside the class program. So let's go ahead and run our application. So again, as you can see, there are no changes. The application works as expected. The reason that we are able to access these variables is because they're all public. So if they're public, they are accessible throughout the application. So let's go ahead and change this public one to a private. So as soon as we change this from public to private, we are getting an error here. And the error is indicating that student first name is inaccessible due to its protection level. So basically what is happening here, we are making this variable private since we are calling it from outside the student class. Therefore, we are getting an error. So let's go ahead and change this back to public. And now if we run our application again, everything should be fine. So please keep in mind that if a variable is declared as public, it can be accessed throughout our application. However, if we are creating a variable with private access modifier, it can only be accessed from within the containing class. In our example is the student class. The last access modifier that we're going to look into is the protected type. So let's go ahead and change student first name from public to protected. Now we can already see an error popping up over here indicating that student first name is inaccessible due to its protection level. So within a class, if we have a protected member, the variable can only be accessed from within the containing class or any other class that it is derived from the containing class, in this case, student class. For example, public class. So let's give it a name, student temp, and this class is inheriting from the student class. Now let's create a very simple function, public void print student temp info. And now let's create an object of our class, student temp st2 is equal to new student temp. Now let's use st2 dot student first name is equal to James. So this is how we can use a protected member. A protected member can only be accessed from within the containing class or any class that it is derived from the containing class. So in this case, we have our containing class is the student and our derived class is the student temp. So we have created an object of student temp. Now we can actually access even a member that it is protected. Return type. Often, methods may return a value. The return type considered to be of primitive type. If a method is not returning a value, then the return type would be void, returns nothing. Method name. Method name should always be unique and case sensitive. It cannot be the same as any other identifier declared in the class. Use meaningful and descriptive words and avoid single characters. Name of functions, properties, and local variables start with a lowercase letter and use camel case and avoid underscores. Parameters. In C#, parameters are used to pass data to a method and similarly receive data from a method. Parameters are optional. A method may not have any parameters list. It is a best practice to limit the number of parameters passed if possible. A parameter list refers to the type, order, and number of the parameters of a method. Parameters are listed after the name inside parentheses and are separated by comma. Method body. The method body contains the actual processes or functionality to process a complex task. It contains a series of statements and instructions to complete a required functionality. Static and instance methods. As indicated earlier, methods cannot perform any function if they are not part of a class. In C#, methods can be either instance or static. An instance method needs to be instantiated, where a static method must be defined as static. Static methods are memory resident and exist in an area of the memory called stack, where an instance method gets created in a separate area of the memory called heap. A static method must have the static keyword in its declaration. Otherwise, the method considered to be an instance method. An instance method is created when needed and removed by garbage collection when it is no longer being used, where a static method exists throughout the life of an application. Consider the main method in a C# application, which is the entry point of an application. The main method must be running prior to any instance class is instantiated. Since the main method is the driver for an application, it always contains the static keyword. Now, time to see some examples. So let's switch to Visual Studios. In this example, we will look into static and instance methods. So here we have a very simple program. We have the main method, then we have two other methods, print student first name and print student last name. So if we look at our first method, we have the access modifier, which is public. Then we have the static keyword and void, meaning that our method does not return any value. Then we have the print student first name, which is the name of our method. And then we are passing a value for the first name. And then we write the result to the console. Similarly, our second method, we have public as access modifier, void, meaning that our method is not returning any value. Print student last name is the name of our method. And similar to the first one, as an argument, we are passing student last name, and then we write the result to the console. So if you look at closely at these two methods, they're pretty much both the same. The only difference is that the first one, print student first name, has the keyword static, where the second one, print student last name, does not have the static keyword. So before we start explaining what is static in instance, let's see how we can invoke each of these methods. Print. As you can tell, the telesense already provides the option for invoking print student first name. And let's pass a name, Smith. Now to invoke the second method that we have, print student last name, since this method exists within our program class, we need to create an instance of our program class. For example, program. So let's give it a name. Last name is equal to new program. Last name dot. Now the telesense does give us the option to select print student last name. So let's select that, and let's go ahead and pass a name for the last name. So let's say it is Sky. Now let's run our application. So as you can see, the application worked as expected. We have the student first name, Smith, and then the student last name, Sky. Now, generally in C#, methods can either be instance or static. Let's consider the main method in our application right over here. So this is our main method. The main method is always the entry point of an application. Since the main method is the driver for an application, it always contains the keyword static, which is right here. Whenever we include the static keyword to a method, the method gets created on the stack and remains throughout the life of the application. Therefore, a static method does not need to be instantiated. Static methods are memory resident and must have the static keyword in its declaration. In our example, print student first name. This method does not need to be instantiated since it has the static keyword right over here. Now, on the other hand, print student last name This method does not have the keyword static. Therefore, prior to calling this method, we must instantiate the method or create an object of the class by utilizing the keyword new, which we've done right over here. As we mentioned earlier, a static method exists throughout the life of an application where an instance method gets created when needed and gets to be removed by garbage collection after a set amount of time. Now, an important point to make: when we create a function or a method, we are utilizing system resources. A good practice, or actually a necessary practice, is to release resources after a task is completed. For example, let's say we want to connect to a database. First, we create a connection to the database, and after the task is completed, we close the connection. Similarly, when we create a method or a function, after the task is completed, we need to shut down the process. Otherwise, the process remains in the memory and it can become runaway processes and can cause all kinds of performance issues or memory leaks. Now, here, once we instantiate a process and after the task is done, within a predefined time, the .NET framework uses the garbage collection process to remove any process that are no longer in use. So to summarize, an instance method is created when needed and removed by garbage collection when it is no longer being used, where a static method exists throughout the life of an application. Method parameters. In C#, there are 4 types of parameters: value parameters, reference parameters, out parameters, and parameter arrays. Value parameters. Parameters passed by value creates a copy of the original parameter, and any change in value does not affect each other. Let's switch to Visual Studios. In this example, we will look into parameters passed by value. As we have discussed, parameters passed by value create a copy of the original parameter, and any change in the value does not affect each other. Let us take a look at an example. Now let's create a variable of a string type. String first name is equal to Walter, council dot writeLine, first name. Now let's create a static method, public static void print name, and we will pass the first name as a string type, so a string first name council dot writeLine first name, and we'll just put in the variable that we are passing to the function or to the method. Now let's make some updates to our application. So let's go ahead and call the print name, and let's pass the first name. In our function, let's change the first name equal to James. So what we have here, we have created a variable of type string, and we have initialized our first name to Walter. Then we've created a method that is static, so we don't really need to instantiate our method, and we are passing the first name to our method, but in our method we are changing the first name from Walter to James, and we are writing the results to the council. So let's run our application. Now, as you can tell, first name James, first name Walter, meaning that when we made a change to the name, it did not affect the original name. So, to summarize this, parameters passed by value creates a copy of the original parameter, and any changes in value does not affect each other. So we can see this throughout this example. Reference parameters. When a parameter passed by reference, the ref keyword is used, creating a copy of the original. However, any change in the value will affect both the original and the copy. Now, time to see some examples. So let's switch to Visual Studios. So as we've discussed earlier, when a parameter passed by reference, the ref keyword is used. Parameters passed by reference create a copy of the original. However, any change in the value will affect both the original and the copy. We will continue to work with our previous example. Let's copy this console.write line, paste it here, and for clarity, we're going to add one here, and maybe 2 and 3 so we can understand which one is being printed. So let's go ahead and run our application. So as you can tell, the first one gets printed, which is Walter. The third one gets printed, which is within our function or method, James. And the last one, which is within our main method, gets printed. Now here, print name, we are changing the value of the first name. So what we can do, we can just add the keyword ref here. And similarly, we can add the ref keyword right here. Now let's run our application. So as you can see, the first name, let me just make this a little bit smaller so we can see the whole thing. Now, as you can tell, the first time that we print our variable, the name stays the same, which is Walter. But then when we use the print name and we pass our variables by reference, then the third one gets printed, and the third one is James. So when we are coming back to the last print, which is number 2, first name also gets to be changed, and it becomes James. So this is how we can change a copy of a variable if we pass it by reference. Out parameters. If a function or method requires to return multiple values, the out keyword is used. Let's switch to Visual Studios. So as we've just discussed, if a function or method requires to return multiple values, the out keyword is used. So here we have a very simple program. We have first name as of type string, and that is equal to JSON, or it has been initialized to JSON. Then we have last name of type string, initialized to Falcon, and we have full name of a string type. And we have a method, print full name. It is static, and it's returning a string value. The name is print full name. We are passing first name as of a string type, and also last name as of a string type. And we are returning the combination of first name and last name. Back to full name. Here we are calling print full name method, passing first name and last name. And whatever this full name method returns, the full name will be initialized with that value. And finally, we are writing the results to the console. So let's go ahead and run our application. Here, as you can see, first and last name is Jason Falcon. Now, this function, print full name, is only capable of returning one value, which is a string type, and that is the combination of first name and last name. So what if we want our print full name method to return 2 values instead of only one value? The first one, first name and last name, and the second one, last name and first name. Now, the first order of business is to add our variables to our argument list. Out string, first, last name, comma. Now, another one would be out string, last, and first name. So let's just copy this and paste. Go next line and just move. There we go. We are already getting errors here. So let's change our return type. Let's copy this one and paste it here. And that is equal to first name plus last name. Now similarly, let's copy this. And here we will copy the second variable and paste it here. Switch these two. And let's put a comma here. Now, the change that we've changed first last name now, which is this variable right here is equal to the combination of first name and last name, where the second one, which is last and first name, is the combination of last name and first name. And the last thing that we need to change is to change the string type to a void type, since we are not expecting any value as the print full name, but we are expecting two values, which is first and last name and last and first name, and we are using the out keyword. Now we are getting an error over here, so that's very straightforward. We are trying to assign two return types of type a string and to one is string type. We'll go ahead and just remove this one. All right. Now to print, so we'll just go ahead and remove full name from here. So instead of that, let's copy this one and paste it. And we can copy this whole line, Control C, and paste. And now change this one to last and first name. And we can copy last and first name and paste it instead of first and last name. All right, now let's go ahead and run our application. Here, as you can see, first and last name is Jason Falcon, and the second one, last and first name, Falcon, comma, Jason. So the application worked as expected. Parameters arrays. Utilizing the keyword params provides the user the ability to specify a variable number of arguments. This can be achieved by utilizing a comma-separated list of argument or an array. Within the method declaration, the params keyword should be the last item listed, and one occurrence of the keyword params is allowed. Now, let's switch to Visual Studios. In this last example, we will look into how to pass an array of integer type into a function or a method. So let's get started. So here, I have created a very simple array of type integer with the name nums. It has 5 elements, nums 0 through 4, which is the index of our array, and each one is initialized to a value. So let's go ahead and create our function or method. Public static void param array params, and then the array that we have created, and open bracket, close bracket, and the name of the array, which is nums. All right. So first, let's get the array length, console dot right line. The length of array is nums dot. We can use the length keyword or the length properties of our array. This will provide us the length of our array. Semicolon. The next one will create a for each loop to go through our array and print each element. For each, we'll create a variable of type integer and count in nums. And we'll go ahead and display the content, console dot right line count. Now getting back to our main, let's go ahead and call our method. And we'll just pass the array name, which is nums. And now let's go ahead and run our application. So as you can see, the length of array is 5, and here each element of the array, so the application worked as expected. So what we've basically done here, we've created an array of integer type named nums, and we have 5 elements for our array, which are all listed over here. And then we've created a method which is static and does not need to be instantiated. It's a type void and it's not returning any value. And then we are using the length parameter for our array to figure out the length of our array. And next we are using for each loop to count through our elements and print the results to the console. This is the end of this tutorial. Please don't forget to subscribe and click on the notifications. Thank you for watching and have a wonderful day.